On number 5, it says a satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles, which are 340 miles apart. Whoa. Already confused? Don't panic. Draw a picture. Let's start with that. We're going to make a terrible assumption for this. Knowing that this deals with trigonometry, we need a triangle. And Los Angeles and Phoenix are not separated by a straight line necessarily. Of course, the Earth is curved. But we're going to flatten it for just a moment. I don't think the curvature between the two of them would really be so significant as to greatly affect the data. In other words, we're going to draw a satellite. I'm a terrible artist. Here's my satellite. It's got a little satellite dish on it, and it's got USA. There we go. There's my satellite. And it's going to pass over Los Angeles, and it also passes over Phoenix, Arizona. Now, if you didn't catch what I had said a minute ago about flattening the Earth, basically we need a triangle. And between LA and Phoenix, you've got the curvature of the Earth to deal with, but we're going to pretend like it's flat. However, my line doesn't look exactly flat. Nevertheless, we need a triangle. There we go. Okay, let's start putting some numbers in there. This is not going to be bad at all. Satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles, and they're 340 miles apart. 340. Let's put the units in there. Be good mathematicians and put the units. At an instant when the satellite is between these two stations, its angle of elevation, okay, pause. Angle of elevation, I'm about to fill in some corner numbers, not side numbers. Angles deal with the corners. It's the measurement of how open an angle is. Its angle of elevation is simultaneously observed to be 60 degrees in Phoenix. That's not the temperature, that's the angle. It doesn't get that cold in Phoenix. It's not cold. Phoenix is a hot place. And 75 in Los Angeles. How far is the satellite from Los Angeles? Whoa, what? Confused. Panic, don't panic at all. Let's switch colors for just a second. Let's erase. Now I'll make my picture of a satellite. I don't have a heart to erase it. Satellite, big S, little s. You with it? This was Phoenix. There's a little Phoenix. That's a lowercase p. I'll put a little hat on him just so you'll know that it's lowercase. I'll erase his hat. There we go. Big P, little p. This was Los Angeles. This is a lowercase Los Angeles. I'll make it kind of curvy so it doesn't look like the number 1. Okay? We have an S, an L, and a P. You can use ABC. It doesn't matter to me. That whole thing rhymed. That was great. The problem says, how far is the satellite from Los Angeles? Because the problem says satellite from Los Angeles, we're tempted to say, oh, I'm looking for L for Los Angeles. No, I'm looking for lowercase p. Satellite to Los Angeles is this segment right here, which happens to be across from big P. So it's little p. I'm looking for that. Let's circle it. Then it says you should draw a picture. Well, we've done that. Let's circle it. There we go. We're looking for little p. Let's come over here and use the law of sines. Whoa, wait. We can't use the law of sines. We can't use the law of sines until we know an angle and a side that's across from it. We know an angle, but we don't know the side. We know an angle and we don't know that because we're looking for it. We know a side, but we don't know the angle. There's an easy way to find it. There's a very easy way to find it. We've done this. We just did it on the last 2 problems. Very simple, very easy. So let's do it. 60 plus 75 is 135. Am I right? Yeah, 60 and 75 is 135. 135 from 180 is 45. I know a lot of you probably grabbed your calculator. Come on, get real. You can do this in your head. That's 45 degrees. Okay? And now we can start the problem. We know an angle, we know a side. Let's do it. Sine of big S over little s equals sine of, looking for P. Don't put an L, I'm looking for P. I know the problem talks about Los Angeles like it's the greatest place on earth, but I'm looking for lowercase p. Sine of big P or little p? Let's keep going. 45, sine of 45 over 340 equals sine of 60 degrees over, don't know, we'll call it p. Just did this, not that big a deal. Cross multiply. 340 times sine of 60. Yeah, put 340 in the front, should have done that to start with. That is equal to p, lowercase p, times sine of 45. In the process of solving for p, and I had a sine 45 right here, I would have to divide by that sine of 45. Let's go ahead and erase it. Basically, I just eliminated writing one step and did it in my head. And this is going to tell me, now, before I even type it in my calculator, keep in mind to check for reasonableness of my answer, it better be in the hundreds. If the distance between these two is in the hundreds, and this is a satellite orbiting the Earth, it better be on up there. This better not be, 2.5 feet, okay? 2.5 miles, 3.5 yards. No. Terrible grammar on that. It better not be no. But yeah, it better be a big number. It's one way to check for the reasonableness of your answer. I won't tell you if you're right or not, but if you get something ridiculously small in this case, yeah. I got it. There we go. Between Los Angeles and the satellite, it is 416.41 miles. Okay, you ready for the tricky part? Okay, this is going to go back to some stuff that you've learned previously. And for some of you, you may not have seen it in a while. This was number 5. Now number 6. Using the same information from the last problem, what's the altitude of the satellite? Okay, let's talk about what altitude is. Altitude is the height. When I measure my height, if I want to know my height, then I'm going to stand up perfectly straight. I'm going to make a right angle with the ground. I better not be leaning and measure my height that way. That's not altitude. Altitude is straight down, which makes a right angle with the ground. There are no right angles in this thing. Let's make one. I'm going to erase my 45, because what I really need to know now is what's my altitude. I'm going to call it A for altitude. I almost called it H for height. Let me tell you why I didn't. If I would have called this H, then I could have easily gotten it mixed up with a hypotenuse. This is not a hypotenuse. It'll never be a hypotenuse. Not in our picture here. And so, not on the way we've drawn it. So, I'm going to call this A for altitude. I need to know A. Okay, before we get carried away, you may want to redraw this. I'm not going to, but for the space that you have for number 6, you may want to redraw it. But let's redraw only the important information. I know this now. I know what it is. I just found it, and I know I'm right. It sounded cocky, didn't it? This is 416.41. Going back to what we learned previously, right triangle trick. I only need a right triangle. This whole picture is unnecessary. I'm going to get rid of all of this. This is going to start looking familiar in just a second. Let's erase that. Okay. This entire distance was 340. Some of you are probably grabbing your calculator right now thinking, well, half of 340, no. No. I'll tell you it's 170 is half 340, but this is not 170. Because between here and Phoenix, this was not necessarily half. So don't be dividing this thing in half just because it looks like half on your paper. I don't know how long that is, and I don't care how long it is. It doesn't matter. This is a right triangle. We've dealt with this stuff before. So again, for those of you that are like, well, I don't know how long this is, and I'll take half of it, don't take half of it. I've seen students do it before. Don't do it. I'm looking for A. let's be realistic. I know this is 75. This is opposite. This is the hypotenuse. Opposite and hypotenuse, this is going to start sounding real familiar. Opposite and hypotenuse is sine. The sine of 75 is equal to opposite over hypotenuse. That we've already found, 41641. We're looking for A. Let's use it. Let's do it. You can consider this as cross multiplication if you like. A equals this times that, so 41641 times the sine of 45. Oops, sine of 75, I'm sorry. Sine of 75. We grab a calculator. 41641 times the sine of 75. .22 miles. And that is equal to A. Let's put it in context. This is not just 402.22. The problem said, how high is the satellite above the ground? The satellite is 402.22 miles above the ground. Make sure you understand what the problem is asking and can explain the answer. There you go.